In the era of Industry 4.0, precise motion control is the cornerstone of intelligent manufacturing. Today, we will explore the core technology of axis control in the S7-1200 PLC, achieving millimeter-level positioning by configuring pulse axes. For the S7-1200 PLC, it supports up to 4 axes using pulse plus direction control, but through the Profinet bus, it can be expanded to 8 axes, allowing a maximum of 12 axes in total. To create an axis object, double-click the PLC, select Create Technology Object, Add Object, and enter the Add Object page, as shown in the figure. Choose Motion Control, then select to Positioning Axis and rename the axis as X-axis. Click OK to create the axis object and enter the axis object configuration page. In the axis object configuration page, under Basic Parameters, General, keep the drive control mode as PTO, pulse train output. Set the measurement unit to millimeters. Under Basic Parameters, Drive Hardware Interface Pulse Generator, select Pulse 1, and choose the Pulse Plus Direction signal type. TIA Portal will automatically associate Q0.0 as the pulse output interface and Q0.1 as the direction output interface. The maximum output frequency is 100 kHz. In the Axis Object Configuration page, under the Extended Parameters Mechanical section, modify mechanical related parameters. Pulses per revolution of the motor is a critical parameter, representing how many pulses the motor must receive to complete one full rotation. This value is set according to the motor specifications. Load displacement per motor revolution indicates the distance the mechanical device moves for one full motor rotation. For example, on a linear work table, if the motor makes one full revolution and the mechanical device advances 5 mm, set this value to 5.0 mm. In screw drive mechanisms, this is determined by the lead of the screw. Set the rotation direction to bidirectional. Software and hardware limit switches are used to ensure that the axis operates within the effective range of the work table. If the axis exceeds a limit switch due to a fault, regardless of whether it is a software limit or a hardware limit, the axis will stop immediately and trigger an error. Limit switches are configured as shown in the diagram. The software limit range must be narrower than the hardware limit range, and the hardware limit positions must lie within the mechanical travel range of the work table. It is also necessary to set the active level for the software upper or lower limit input points, which is typically set to active low. The software limit values are calculated relative to the 0 point. Once configured, they take effect. It is recommended to perform a homing operation before setting the software limits. Therefore, the coordinate range of -940 mm to 3.0 mm is defined with respect to the home position. In the Axis Object Configuration page, under Extended Parameters Dynamic General, set the motor's maximum speed and starting speed. As shown in the diagram, changing the speed limits will affect acceleration and deceleration, while the acceleration time and deceleration time remain unchanged. As shown in the diagram, emergency stop-related parameters for the motor can also be configured. Homing parameters must also be configured, as shown in the diagram. This includes active homing and passive homing. Active homing. After initiating a homing operation, the axis automatically moves to locate the reference point. Passive homing. The axis does not actively move to perform homing. Instead, when the servo encounters the homing switch during its motion, the 0 point is set. The home position is also referred to as the reference point. The purpose of homing, or searching for the reference point, is to align the axis's actual mechanical position with its coordinate position in the S7-1200 program, thereby enabling absolute positioning. In general, Siemens PLC motion control requires performing homing or searching for the reference point before enabling absolute positioning. In extended parameters, homing, active, the term active refers to the traditional homing or reference point search. When the axis triggers an active reference point search, it will move at the configured speed to detect the homing switch signal and complete the homing command. The following parameters need to be specified. Input homing switch, active level selection, allow automatic reversal at hardware limit switch, approach homing direction, reference point side, approach speed, reference speed, home position offset and reference point position. Input homing switch, used to set the DI input point for the homing switch. Active level selection, used to select the active level of the homing switch, that is, whether the DI point corresponding to the homing switch is high or low when the axis contacts the homing switch. Allow automatic reversal at hardware limit switch. If the axis does not contact the home position in one direction during homing, enabling this option allows the axis to automatically reverse and search the home position in the opposite direction. Approach homing direction refers to the initial direction in which the axis searches for the home position. In other words, once the homing function is triggered, the axis will begin searching for the home position either in the positive direction or the negative direction. As shown in the diagram, since the reference point is currently on the right side, performing a homing operation in the positive direction will suffice. When the mechanism triggers the sensor, it activates the homing signal. However, since the mechanism itself has thickness, it is necessary to specify left side and right side, as shown in the diagram. Upper side, in reference point side after the axis completes the homing command. The left edge of the axis stops at the right edge of the reference point switch. Lower side, in reference point side after the axis completes the homing command. The right edge of the axis stops at the left edge of the reference point switch. Regardless of whether the user sets the home position search to start in the positive or negative direction, the final stop position of the axis depends on whether upper side or lower side is selected. Approach speed refers to the initial speed at which the axis moves to search for the homing switch. After the MC home instruction is triggered in the program, the axis immediately runs at the approach speed to locate the homing switch. Reference speed refers to the speed used when finally approaching the homing switch, i.e., the speed at which the axis moves after first contacting the active edge of the homing switch. Specifically, after triggering the MC home instruction, the axis initially moves at the approach speed. Once it reaches the active edge of the homing switch, the axis switches from approach speed to reference speed to complete precise homing. The reference speed should be lower than the approach speed, and neither speed should be set too high. Within acceptable limits, slower speed values are recommended. The home position offset refers to the distance at which the axis stops from the homing switch when the value is not 0. This distance is the offset, and marks that position as the home position. If the value is 0, the axis stops at the edge of the homing switch. This lesson provides an in-depth analysis of the core configuration process of the S7-1200 PLC motion control system, creating the technology object, configuring the PTO interface, calibrating mechanical parameters, constructing a safety protection system, setting the homing strategy. Together, these steps establish a closed-loop, industrial-grade precision motion control system.